And instead of like addition and subtraction, where when you added or subtracted vectors, you got a new vector, the dot product of two vectors actually results in a number, in a scalar, instead of a vector. So here's how the formula works. If I take u and v, u dot v is found by taking the x components and multiplying them together, then taking the y components and multiplying them together, and then adding those two products. So let's see what this one is actually asking us to do. Find u dot v times w. And notice that's a times, it doesn't have the dot. That dot is actually special in the vector world. So let's start with u dot v. Well, u dot v means I'm going to take the x components and add that to the y components multiplied together. So that gives me -2 plus a -12. That is a -14. Now, according to order of operations, the next thing I did, what's in parentheses? The next thing I'm going to do is multiply times w. So now I have a scalar times a vector. Now that will result in a new vector. U dot 2v. So the first thing we need to do is take 2v. So we're going to be taking u dot 2v. Well, 2v would be twice each of those components, so that's 4, -8. And it's dot product with u, so I'm going to u dot 2v would mean I'm going to take the x components and multiply them together, so -1 times 4 plus 3 times -8. And I will get -4 plus a -24, and that's a -28. Let's remind ourselves, what does this mean we're finding? Well, that means I am finding the magnitude. And we're just reviewing that because we'll be using that in just a little bit. Now, the magnitude is where you use Pythagorean theorem, basically, or distance formula. It's the square root of the x component squared plus the y component squared. So that's going to give me the square root of 1 plus 9, and that's the square root of 10. We'll need that here in a little bit, because the main thing that dot products are good for is finding the angle between two vectors. So let's say we have vector u and vector v, and they're both their starting points are at the same place. So that ends up giving us v minus u instead of u plus v. And we want to find the angle between those two vectors. Well, here's the formula for it. The cosine of theta equals u dot v divided by the magnitude of u and the magnitude of v. So let's break that down. I like to take it piece by piece. So I like to find u dot v first. Well, u dot v means I'm going to multiply the x components together and then multiply the y components together. And so that's 12 plus 15. That's 27. Now, I also need the magnitude of u. Square root of the x component squared plus the y component squared. That's the square root of 16 plus 9. the square root of 25, which is 5. I also need the magnitude of v. That's going to be the square root of this x component squared plus the y component squared. And that's going to give me 9 plus 25. That's the square root of 34, which does not reduce. So, the cosine of the angle equals u dot v, which we found to be 27, over the product of the magnitudes. Now, how do I work backwards to find that angle? Well, we're going to use inverse cosine. So, inverse cosine. Whoops, let me make sure I'm in degrees. Okay. Back to here, inverse cosine of fraction 27 over 5 square root of 34. Enter. The angle is 22.17 degrees. Now, there's something called orthogonal vectors. And I know that's a big word, orthogonal. That means perpendicular. Vectors are orthogonal if their dot product is 0. And let's see why that's true. So if their dot product is 0, then cosine of theta would be 0 over their magnitudes multiplied together. Where 0 divided by anything is still 0. And the inverse cosine of 0 is 90. So orthogonal means they're perpendicular. And so we don't have to go through the whole process of finding the angle. If we know that u dot v is 0, then they're automatically going to be 90-degree angle. So they're going to be orthogonal. Okay, so the dot product means I'm going to multiply the x components together and then multiply the y components together. So that's 12 plus a negative 12, and lo and behold, it's 0. So yes, they, are orthogonal or perpendicular. Now, what if I wanted to take a vector and decompose it into two perpendicular components? And what I mean by that is, let's say I have the projection of u onto v. What this means is, let's say I have, here's u, and here's v. I'm just making something up. The projection of u onto v is made up in two parts. So we have this x component. I'm going to call that w 1. And we have this vertical component. Call that W2. W1 is the projection onto V. In other words, it's the shadow that U makes. And it is found by this formula. This is finding that cosine of the angle times V. That's going to give me my X component. Cosine of the angle times V will give me that X component. So, find the projection of U onto V. We don't have to draw the picture. We can do all this algebraically. So to find the projection, the first thing we're going to do is find W1, that horizontal component. And it is found by finding this projection. So it is found by doing U dot V over the magnitude of V squared. Then we're going to multiply that times V. So the first thing I need to do is find U dot V. So I'm going to come down and do a little work here. So I'm going to do U dot V is multiply the X components together plus multiply the Y components together. So that's 18 plus negative 10, that's 8. I also need to know the magnitude of V. And that's going to be the square root of 6 squared plus 2 squared, which is 36 plus 4, that's 40. So U dot V was 8. The magnitude of V was the square root of 40. And I'm squaring that. Oh, that makes it nice. Times V. So I end up with 8 over 40, which I could reduce to 1/5, right? I'm having one of those mornings. Yes, 1/5. So let's rewrite it as 1/5. 1/5 times V. And V was this vector. So I end up with a new vector. This is vector W1. It's this projection here. It's the shadow. Now to find W2, all I have to do is take U minus the vector we just found. So I'm taking U minus the vector we just found. Now the problem on this comes in that if you have trouble working with fractions, this can get a little tricky. But if you have a calculator, you can do it in the calculator. I'm going to show doing it by hand. I want them all to have the same denominator. So I'm going to rewrite this as 15 fifths and negative 25 fifths minus 6 fifths and 2 fifths. So I get 15 minus 6 is 9 fifths, and negative 25 minus 2 is negative 27 fifths. That is W2. So what we're doing is we're rewriting U as its two components. So U can be rewritten as W1 plus W2. We're going to do this next one. If you want to try it on your own and then check your answers, you're more than welcome to do that. So I got u dot v to be 14. I've got to take this and square it, so it's just going to become a 37. I don't think that simplifies. It does not. So times vector v. So 14, oops. 14 times 6 is 84. And then, oh, luckily that's a 1, so that makes it easy. Sorry about that. I'm at the school again. That's my first vector I'm looking for. Now I want the one that's orthogonal to that. So I find that by taking u minus the one we just found. So u was 2, 2 minus this new vector. And so to subtract fractions, I need to have a common denominator. So 37 times 2 is 74. So 74 over 37, 74 over 37, minus 84 over 37, and 14 over 37. When I subtract, 74 minus 84 is negative 10. Then 74 minus 14 is 60. And that's W2. So now the last step is to rewrite U by adding those two together. Can I pause the recording? I can't, so hold on. Let me write this real quick. I can't pause the recording. Plus vector W2 and that's dot products.